All right, everybody, we are looking right now at the first section of topic 13. Okay, topic 13 starts with a couple of vocabulary words to fill out your perimeter and area. Okay, the reason we put both of these on there is because even though we are going to be using perimeter later on in the unit, I wanted to differentiate between these two things. This is something that a lot of kids get mixed up on. Okay, we are interested in this unit in finding the area of different polygons. Okay, different shapes. And in order to do that, we have to be absolutely clear that the area is all of the space inside of the boundaries of a shape. Okay? We have to be absolutely clear that that is what your final answer should be, not the perimeter. Okay? Do not add up all the sides of the shape and expect to get a good answer on your assignments. That's not what's going to happen. Okay? We've got the area. That is what we are trying to find in all of our problems starting today. Okay? So, as a matter of quick review, we've got the area right here, the area of a rectangle. Okay, and we all know how to find the area of a rectangle. I am not about to teach a fourth grade level math lesson about how to find the area of a rectangle. It's length times width. So when you see this 7 and 3 over here, that's your length and width. Okay, so if we're looking for the area of this particular rectangle, it's 3 times 7. It's 21 square centimeters. Okay, the area of a rectangle is not something that we should ever get super mixed up about. Okay. But the reason we're reviewing that right there is because of how it relates to the area of a triangle. Now, we know that if you take a rectangle, like if you took this whole entire thing right here that I'm outlining in red, and you cut it in half along the diagonal, it turns it into two triangles. Okay, and if we were finding the area of that rectangle, the length times width, we would be finding the area of two of those triangles. So if we just take that length times width and we cut it in half, that would give us the area of this right here, just one of the triangles. Okay, so usually on a triangle, we don't call it length and width, we call the two dimensions base and height. Okay, and the base and height can be presented in a bunch of different ways because, well, honestly, there's a lot of different kinds of triangles. Okay, but that formula is something we're already familiar with, probably from middle school mathematics. You've got 1/2 times the base times the height. Or the other way we usually see this formula, what we're going to be using today, base times height divided by 2. All right, so that's your area of a triangle, and that's what we're going to look at these first couple of problems. All right, this first one right here, it's pretty easy to tell what your base and height are. This is a right triangle. Okay, so the base is just going to be this one right here, number 8, and the height is going to be 6. Remember, something important to remember that the height and base are always perpendicular to each other. Okay, so if your area is base times height divided by 2, those are the two numbers you need, your base and height. So we plug them in, and it's just 8 times 6 cut in half. 8 times 6 divided by 2. So we get an area of 24 for this triangle. Going on to our next one. On this one, we've got a base of 11 inches and a height of 3 inches. Once again, it's important to note this fact right here, that base and height are always perpendicular. Base and height, always perpendicular. Okay, so as we look at that, we've got our base, which is 11. Our height is 3. And so we just plug it in. 11 times 3, cut it in half. And there's your area right there. Our last example right here is where it can get a little bit difficult. Okay, you can see just by those first two examples that the calculations on these problems are not very complicated. But sometimes the diagrams have information that can mess you up, that can change how you're looking at it. Okay, so here's what I'm looking at. Okay, what I'm going to do is I'm going to highlight the thing that we're actually dealing with in this problem. Okay, we are worried about finding the area of that triangle that I just highlighted. Okay, this extra stuff outside on the dotted lines, it sometimes has good information. For example, we can tell from this that our height, we can already tell from this that our height is going to be 10.4. However, our base does not have anything to do with this number right here. That is not going to be our base. That is extra information. Our base is 5.5. So when we plug those numbers in, after we have figured out what the numbers are, the process is just more of the same. Okay, multiply them together and cut it in half. Do all that, we get our final answer of 28.6. Come around now to the next page where we talk about the area of a parallelogram. Okay, first I want to talk about some parts of the parallelogram. Okay, when we talk about these things, on a triangle we use base and height. Well, when we talk about the area of a parallelogram, we're also going to be talking about the base and height, but it's not necessarily the same thing. On a parallelogram, the base could be referring to any of its sides. Okay, so obviously this part down here could be a base. Okay, the what we usually think of as the bottom of the shape, that's what we usually think of as the base. But really, this could be a base. This one right here could be a base. Any of those sides could be considered bases, depending on what your height is. Let's talk about this. Let's talk about our other thing, the height. Okay, the height is just the length of an altitude. So you're asking yourself, what in the world is an altitude? Okay, an altitude is a line segment that's perpendicular to the base. Okay, I'm going to draw a couple of altitudes right here. On our previous problem, that dotted line that dropped straight down from the highest point to the lowest point, that was an altitude. Okay, and on that previous problem, we actually had it where the base was extended out and the altitude was dropped down like that. Okay, that dotted line is the altitude. And when you take how long is that line, that is where you get your height from. Okay, so when it's labeled with a number, that's what your height is. All right, go along and look at our examples here. Okay, actually, before we get to the examples, look at this. Okay, we have in this picture a parallelogram. Okay, a parallelogram has 4 sides, and the defining characteristic is that the opposite sides are parallel and congruent. So, what we have is a parallelogram that's been split into two sections, I guess. And when you cut off this section here on the end, this triangular section, and move it over to the other side, all of a sudden you've got a rectangle. Now we know that this rectangle has the same area as the parallelogram up above it because it's made of the same pieces. Okay, and the area of this rectangle is the length times the width. Okay, that's the length times the width. Well, y'all, the area of this parallelogram would be those same numbers multiplied together. The length times the width. Okay, but on a parallelogram, we don't call it the length times width. What we call it is base times height. Okay, base times height is what we're dealing with here. Okay, base times height, that's what we're dealing with. So that ends up being our formula. Okay, so as long as you can figure out what is the base and what is the height, that becomes a very easy formula to solve problems with. Okay, when you look at this first example, the base very clearly is labeled 14 feet. The height is also very clearly labeled 3 feet. So if you're looking for the area, you just multiply those things together. 14 times 3 and we get an area of 42 square feet. Look at our next example. Our next example, actually, no. We're going to go to this one next. Okay, on this one, keeping in mind that your base and height are always perpendicular to each other, we can clearly see that our height is going to be this one right here that drops straight down. Our height is going to be 4, but our base is going to be this thing right over here. Our base is going to be 3.8. Okay, so base times height tells us 3.8 times 4. And we multiply those together and we get our area. So here's the question. What is going on with 9.5 in the middle of all this calculation? And the answer is that it's a trick question. Because you know what's going on with 9.5? Absolutely nothing. 9.5 is not involved in these calculations at all. It's extra information. It's designed to throw you off. And on a multiple choice test, 9.5 times 3.8 would absolutely have been one of the answers. 4 times 9.5 would have also been one of the answers, and neither one of those would have been correct. Okay? So you need to watch out for that extra information and be sure when you look at the diagrams, you're able to pick out which numbers you should be plugging in to your formula. Go now to this problem. Okay? On this problem, your first instinct is to look at this picture and say that 10 must be your base. Okay, but if 10 is the base, think about this. If 10 is the base, what is the height? Okay, if 10 is the base, then the height would have to be something out here. That is a number we do not have in this whole entire problem. Okay, that's a number that we don't know what it is. So here's what we're going to do instead. Okay, all of that would be wrong. So here's what we're going to do instead. What if we took this parallelogram and we turned it up like this? And when you turn it up like that, you can clearly see that this line right here is dropped straight down. So your height is going to be 12. And your base would be this one right here. And your base would be 8 because it matches the other side right here. Okay, so when you're multiplying base times height, it's 8 times 12. Okay, there are some problems like this as you work on some of your assignments and some of your quizzes and tests moving on. There's some stuff like that where you need to watch out for which number you're using as your base. Because again, if this was a multiple choice test, 120 and 80 both would have been answers, and they both would have been incorrect. All right, so that's what we're looking for on in the world of parallelograms right there. We've got one more problem to get to, and it's talking about coordinates, okay? And I'm just going to tell you, do not even bother writing down these steps, okay? We're going to make this quick and easy. These steps are, if we wrote down those steps, it would just make it more difficult. So here's what we're going to do. We're going to take this right here, and we know that our area for a parallelogram equals base times height. Okay, we already know that. So if we're looking for the length of the base, can we just take a pencil and count? 1, 2, 3, 4, 5. Look at that. Your base equals 5. And then what we could also do is take our pencil and count the height. Okay, we know that the height is going to be the length of that dotted line right there, the altitude. And we can just count it. We go 1, 2, 3, 4 squares down. Look at that. Ooh, that got messed up. Look at that. Our height equals 4. So if we're multiplying base times height, y'all, it's just 5 times 4. Don't make this harder than it has to be. Don't overcomplicate a problem like this that's going to be an easy one. Your area is just 20. Okay, that's all we're going to have for today's notes. Your assignment problems are going to look like this right here. Okay, there's nothing too difficult. I will give you one quick hint though. On this last problem right here, here's a hint for you. On this last problem, make sure you check the side lengths. Make sure you are only counting side lengths, not going by coordinates. Okay, so count the side lengths on that one. And that's the only advice I can give you right there. I think everything else is pretty straightforward. All right, so y'all get after it. Have a good day.